Hello and welcome to Lesson 11 in the online terrestrial navigation course. Today's lesson is on mid-latitude sailing. As always, there's a worksheet in the description of the video. Click on that link, you can download the worksheet and follow along. While you're there in the description, you'll also see a link to my Patreon page. I recently created that. You can click on that link and subscribe for as little as $5 a month. If these videos are helping you out, I would certainly appreciate the financial help from your end. I'd like to send a shout out to David B., who was my first subscriber on Patreon. Really appreciate that, David. Hope these videos are helping everybody out. Throw me a bone there. Uh, Hop on over to Patreon and subscribe to the page. All right, so let's jump into today's lesson. The sailings, as you may know, are a group of equations we use to calculate either a latitude and longitude at an arrival point, or we can use them to calculate a course and a distance between two points. There are several different types. We have mid-latitude sailings, we have Mercator sailings, plain, um, great circle sailings, but your questions on the Coast Guard exam will um, tell you to calculate something by mid-latitude, or it will tell you to calculate by Mercator. Um, and each one of those equations, you'll get a little bit different answer. So it's important that if the question tells you to calculate it by mid-lat, then you use the mid-lat equations. So today's lesson, we're going to calculate by mid-latitude sailings. So let's take a look at uh, the types of questions that we'll get on the exam here. There's two types of questions that the Coast Guard will ask you. You'll always be given Lat 1 and Lambda 1, and then they'll either uh, give you a course and a distance, and you'll be required to calculate L2 and Lambda 2, or you'll be given L2 and Lambda 2 and be required to calculate a course and a distance. We kind of touched on this in lesson 9A um, with they gave us a course and a distance, and we calculated L2 and lambda 2. I mean, we did it in a little bit different way. This is a little more in depth here, what we're going into. So when you're given a course and a distance, we'll use the following equations here. And these equations are printed in Bowditch, but I have them a little bit different here, whereas we divide by 60 right here for your difference in latitude, and we also divide by 60 for your difference in longitude. Um, the equations that they print in Bowditch, they do not give you this divided by 60 on it. But if you memorize these equations in this form, this is how you have to use them in the calculator that we'll be using. These equations right here are the two that you'll use if you're given a course and a distance. Now, if you're given L2 and lambda 2, we use these equations. Tangent theta equals cosine of the mean latitude times the difference in longitude divided by the difference in latitude. At this point, it would be a good idea to pause the video and just write these equations down and write down when you will use them. So given a course and a distance, you'll use these two equations. Given L2 and lambda 2, you'll use these two equations. And that's just as important as learning the equations themselves is learning when you will use them. So if you can memorize the equations, but not only memorize the equations, but also memorize when you'll use the equations. And to calculate mid-latitude, it's just simply L1 plus L2 divided by 2. And you will use this little equation here in every every question, just just the average, L1 plus L2 divided by 2. So again, if you want to pause the video here, get some scratch paper, write these equations out, write down when you will use them. Um, that is the main focus of this lesson. You have to know that before you can get into working the problems. All right, well, I'll give you a second to pause it, start memorizing, and after that, come back to the lesson. Okay, so let's take a look at the first type of question we'll see with the mid-latitude sailings. This is question 1 on your worksheet. The question is giving us a distance and a course, L1, lambda 1, and it wants us to calculate L2 and lambda 2. So given this information, we need to ask which equations we're going to use. And with this information, we'll use the following equations. The dl, the lm is in every equation, and the d lambda. So let's scoot this to the side on our scratch paper. And the first thing we're going to do is convert our L1 and lambda 1 to a decimal. We learned how to do that in lesson 6A. So I'm not going to go through that on the calculator, but we're converting it to a decimal because the calculator likes decimals way more than it likes degrees and minutes. So we're going to use the following keystrokes on our Texas Instrument 30XA to calculate this. We'll say distance times the course cosine divided by 60 equals, and we'll get that 720 and that 58 from the problem, and we'll key it into our calculator. We'll say 720 times the course of 58 degrees, and we'll hit the cosine button. We'll divide that by 60 and hit equals. We'll get 6.359. And if you remember back in lesson 9A, a positive number here that we calculate is going to equal north latitude. And we got a positive, and we're going to round everything to 3 decimal places uh, in this lesson. So we're just going to put 6.359. It's positive, so it's north latitude. And let's put that over here for our difference in latitude. Got north latitude, L1 is south, so we subtract there. And now we'll calculate the mean latitude, just simply L1 plus L2 divided by 2. That's pretty simple, so I'm not going to key that into the calculator. Just remember that you have to use your parentheses on your calculator here, or you'll get a jacked up answer. Well, we come up with 26.921 here, and now we'll calculate uh, the difference in longitude using the following keystrokes on the calculator. Okay, so we will clear that out, and we'll say 720 for our distance. Times the course of 58 degrees, sine divided by our LM, which we got right here, is 26.921. Cosine divided by 60. equals 11.413. And if you remember back in lesson 9A, a positive number for your DL is going to be east longitude and a negative number is going to be west longitude. Here we get a positive number. So it's going to be east longitude. And when we apply it to our lambda 1, since lambda 1 is east and our correction is also east, we will add that correction. Which gives us 43.113 east for our L2 or lambda 2. Now we need to convert that back to degrees and minutes, and we simply just multiply the decimal by 60. Comes up to 44.4 south. And we do the same thing for our lambda 2, multiply the decimal by 60. Now here you'll notice that it's not the exact book answer. I was told a long time ago when the Coast Guard started calculating these problems, they used the sine, cosine, and tangent tables to calculate this, which will put the decimals just a little bit off. I think in this lesson, there's only one problem where the answer comes out exactly on the money. So don't be alarmed about that, just a few tenths off. So that is how you do the first type of question. Now let's take a look at how we do the second type of question. Okay, so the second type of problem you'll see with the mid-latitude sailings looks like question 6 on your worksheet. You're given L1, lambda 1, L2, and lambda 2, and the question asks you to determine the true course and distance by mid-latitude sailing. So we need to ask ourselves, what equations are we going to use to solve this? So given L2 and lambda 2, we're going to use the following equations. The mean lat equation, which we use in every problem, the tan theta, and the distance equation. So let's set these over to the side. And then the first thing we'll do is convert all these lat and longs to decimals. Rounded, notice we round them to 3 decimal places. And this was covered in lesson 6A. If you're lost with this, hop back over to lesson 6A, and that's where we go over this. Okay, so now we can get DL and D lambda simply by subtracting the smaller from the larger. But this is something you have to look at here. If our L1 is 28.9 north and we're traveling to 24.4 north, we're going in a southerly direction. So our DL is going to be south, and it's 4.517 degrees. That south is pretty important there. That's where a lot of careless errors are made right here. But if you look, if you're in northern latitudes and you're going from 28 to 24, you know you're going south. Over here with our longitude, if we're in west longitude and we're going from 89 to 83, then we know that we're going east. So we're going east by 6.167 degrees. These labels are pretty important. We'll use them a little further along in the problem, but that's something that you have to be aware of there. And so now we have our DL and D lambda. So let's scoot that to the side and we'll calculate our mean latitude the same way we did in the other problem. Come up with 26.659. Now that we have these 3 tidbits of information, we can calculate theta. Theta is not the course, but it's going to be a number that tells us how to get the course. And the way we calculate this is with the following keystrokes on our Texas Instrument 30XA. Um, let's put this over here so we can see everything. Our LM is 26.659. Cosine times our d lambda is 6.167. And we're going to divide that by our dl, which is 4.517, equals, now that is the tangent of theta. So to get theta, we'll have to hit second tangent. It comes up to 50.66, which we can round to 50.7. That's going to be theta, is 50.7. All right, so let's scoot the calculator out of the way for a minute. Now that we have theta, we can calculate the course, and this is how we do it. This is where I told you our south and east comes in important. Our D latitude, we're going south, so we are going 180 degrees, and then our longitude, we're going east. So we start at 180 degrees. If we were going north, we would either start at 0 or 360, but here we're going south and then we're going east. So we're swinging our course from 180 degrees back towards the east, and we're swinging it by, yep, you guessed it, theta. So if we're going back towards the east from the south, we'll subtract that 50.7 from the 180, and we get 129.3, and that is our course. And now we can calculate our distance. Now that we have a course, we can calculate our distance with the following keystrokes. So let's bring our calculator back up, clear that out, and we'll say our DL is 4.517 times 60 divided by the course, which is 129.3, cosine equals. Now here, the negative sign, it doesn't matter. That's a distance of 427.89 miles. So the positive or negative here does not matter. It's just there's the distance, 427.8. And if we look at our answers here, answer B is 427 miles and 129 degrees true. Again, the decimals are not exact, but when you're talking 8/10 of a mile over 427 miles, that's not really that big of a deal. All right, well, grab the worksheet out of the description. Don't forget to check out Patreon. Throw me a bone there. Maybe I can buy a better laptop that responds a little better in these videos. All right, if you have any questions, comments, leave them in the comments. Give us a like and a share. Subscribe to the page, and we'll see you next lesson.